Okay, so here we are going over gradient boosting, in which the goal is to create predictive models by combining multiple simple models, such as decision trees, that basically enhance the overall accuracy and strength of the final model. So it goes through an iterative process where it gets better and better with each time that it passes through in order to improve its accuracy score. So in this case, this demonstrates gradient boosting. We start out with importing our libraries that's needed and importing a data set. In this case, I'm importing a data set from sklearn and then load the data set I chose was wine for the example. So I'm loading my x variable and my y variable, the data and the target. So you can see what those are. And then the next block of code, what we're doing is we're importing, we imported the necessary libraries, but we're going to split the data sets into training and tests. Then we're going to initialize the test model on the gradient boosting classifier. So it uses that to evaluate the model using the threefold across the validation. So we're talking about the mean score, the cross value score, and then it compares the training x and y value in order to come up with the actual output, the final mean cross validation score. In this case, it came out to be 9.9221. So now we've got that. That's the first iteration passed. So now what we want to do is we want to define some parameters um, for our grid, right? The hyperparameter of tuning the machine language model for the tree-based algorithm. So here we have the in estimator. So we're going to define a number of trees um, that's used, and then the learning rate. So how much the model adjusts for each iteration. So each time it passes through, what is the learning rate or each one. So here we've got 0.0001, 0.001, and then it increases from there. So you can pretty much pick what you like in terms of preference, and these were the values that I selected for this. And then the last one is the max depth, which sets the maximum depth for each decision tree. And then moving down, we are now looking for our gradient boosting number 2. So this is the second iteration of that. The second value is going to go ahead and fit between those parameters, the x train and y train. And in this case, it went through the second iteration starting with the best parameters from what was selected earlier, what was the parameters up here, up top of these values, the best parameters that we can use are options here. And it gave us an improved score using those best parameters of 0.9434. So in here, basically, I wanted to demonstrate the difference or the gap between the first iteration and the second iteration was a 0.0212. So you can see how this can get even more precise with each iteration that it passes through. So basically, in short, gradient boosting is like, you have a team of weak players and you eliminate the weakness. You work together, you learn from the previous iteration to get better. You learn from mistakes and become, even stronger in making your predictions.